In this unit, we will explore the key aspects that a designer should consider to ensure a successful import into GeneXus. We will mention some key strategies and approaches to maximize the effectiveness of the design and facilitate its integration. Let's start with variants. Why is it important to create and use variants of our components? Variants allow you to manage different states of a component, such as hover, active, and disabled for buttons, or sizes like small, medium, and large for cards, among other options. These variants are configured within the same component in Figma, which improves organization and makes it easier to select the desired variant when using the component. It's important to note that, although variants allow you to define multiple configurations of a component in Figma, in GeneXus they are considered separate components. However, it is recommended to use variants as a best practice, because it not only organizes the design file, but also makes it easier for developers to understand the functionality of each state. It's worth mentioning that importing each variant as a state in GeneXus is not done automatically. Depending on the case, they will be imported as independent components that the developer will need to manually identify throughout the application. Let's move on to explain this with some examples. In the case of buttons, as we mentioned earlier, we can define the various states that each button can have and their different instances, as well as the hierarchy that exists among them. In this way, we can create a complete collection of all the buttons and their respective states that are found in the application's design. In GeneXus, each of these variants will translate into a different button control. The name we assign to each variant will give the developer information about the state or style it represents. There are two fundamental considerations we need to keep in mind. First, each variant must be properly named. By default, Figma names the variants as follows. Property 1, same name as the frame where the component is located. If we leave these default names, importing the button objects will be confusing and hard to maintain in GeneXus. It's crucial to define each variant in a semantic, clear, and unique way. For example, we could define a property called state and specify the state of each variant, such as state default, state hover, or state disabled. Secondly, since we're working with buttons, it's important to follow the appropriate convention so that GeneXus interprets them correctly. In this case, we need to use the button convention as a prefix in the layer name. Let's continue with the icon example. In this case, we can create a complete collection of icons using variants, which will allow us to quickly switch between them according to our needs. To ensure an effective import, we need to follow 4 recommendations. First, it's essential that all icons have the same size and style. This ensures visual consistency and prevents distortion when using them in component instances. Second, we need to consider all the colors in which we will use each icon. We already explained this in more detail in the overview module. It's important to express all colors as variants and avoid making changes directly in the component instances. Third, it's essential to mark all icons for export in at least 3 densities. And if the project is for the web, add an SVG extension. Finally, just like in the previous case, it's crucial to rename each variant correctly to make it easier to identify and use during development. Each of these variants will be translated into an object, a different image in GeneXus. And once again, the name we assign to each variant will give the developer information about the state or style it represents. Finally, we will analyze the card example. In this case, we'll use different sizes for each card, keeping in mind that each one is designed for a specific device, such as mobile, tablet, and desktop. This approach not only helps maintain a consistent appearance, but also makes it easier to select the right variant depending on the device. It's essential to be precise when naming the properties and states of each variant. In this case, we call them small, medium, and large. But we could also choose to use device names for greater clarity. It's a good idea to discuss these names with the project's developer to ensure better agreement. In this case, Genexus will interpret each of these variants as a stencil object. As an extra recommendation, in all these cases, it's essential to use frames instead of Figma groups. The main reason for this recommendation is that frames allow for better organization and control over the elements within them, making it easier to manage the layout and behavior of the components that will be imported into Genexus. Groups are more limited in their functionality and don't offer the same flexibility as frames. We will use groups in exceptional cases, such as when we have a complex illustration within our design that needs to be exported as an image. In this case, grouping the illustration elements can facilitate handling and export. In summary, using variants in Figma is a good practice that improves design organization and makes integration with Genexus easier. Implementing them correctly helps create a more efficient and manageable design system. This results in more maintainable and effective development. Let's move on to the next recommended best practice: semantic renaming of layers. Just as we mentioned in the case of variants, naming layers semantically in Figma is crucial so that Genexus can correctly interpret each element and its function in the application. A good naming system allows both designers and developers to quickly understand the intention behind each layer, which makes collaboration easier, and it reduces errors during the import process. When we talk about semantic naming, we mean describing the function of each layer as clearly as possible for its correct interpretation. It is essential that both the naming convention and the way each layer is named, once again, are discussed with the developer to maintain a consistent structure throughout the file, which will lead to a more organized development process. Let's look at some recommendations for naming layers. Avoid using default names for layers, for example, Rectangle 789. Use semantic names that are as descriptive as possible. Do not use emojis. Avoid inconsistent combinations of uppercase and lowercase letters. Use alphanumeric characters for layer names, always starting with a letter and removing any white space at the beginning or end. Keep layer names concise but meaningful, with a maximum length of 128 characters. We've often come across files where text layers, for example, use lorem ipsum and the entire paragraph they just copied ends up as the layer name. Avoid duplicate names, both in frames and components. And finally, keep in mind that in the case of duplicate names, Genexus will automatically add numeric suffixes, for example, button, button1, button2, and so on, which compromises the maintainability of the application. Now let's look at an example of how to approach semantic naming starting from a component and its instances. For example, if we have a component called ButtonPrimary, when we instantiate it, its name should indicate the function it is fulfilling. In this case, ButtonLogin. In conclusion, we can say that by working this way, we achieve an organized file with recognizable and consistent names, which will be very useful for maintaining clarity in our Genexus knowledge base and providing essential information to the developer. Later on, when we cover the specific adjustment modules, we'll see that the person in the integrator role will need to add specific conventions for Genexus, such as prefixes in these layers that we have already renamed. Some of these conventions were mentioned in the previous introduction module, and we will be going deeper into them in the following modules. The next best practice to address is designing responsively. Responsive design ensures that interfaces adapt to different screen sizes. Just as we saw throughout Module 1, these properties are also translated into Genexus and have a direct impact on development. Therefore, it is essential that we design with screen variations in mind. Let's suppose we are designing a desktop application. We can't predict the exact dimensions of every screen that will display our application in the future. To anticipate this, we can establish how each element on the screen will behave and decide what I want to happen with each of these elements in every case. Let's look at an example. Here we can see a screen from our application. If we increase the width of the screen, we notice that the elements themselves don't change, but instead move to the left. This indicates that they are pinned to one of the sides. In contrast, if we decrease the size of the frame, the screen gets cut off. When we properly adjust the responsive properties, if we increase or decrease the size of the frame, the elements scale appropriately to fill the new space. It's important to clarify that these adjustments are only effective if the changes in screen size are minimal. We can't expect the same design to simply adapt from desktop size to mobile. Later on, in the Settings module, we will take a closer look at these properties, which are essential for efficient importing. In summary, designing responsively is not only an essential practice in design, since it allows us to anticipate how elements will behave and ensures they adapt to a wide range of screens, but it is also fundamental for impacting development when importing our files into GeneXus. Throughout this unit, we have covered a series of fundamental best practices for designing and developing applications in GeneXus. By applying them, we not only improve the quality of our files, but we also optimize the workflow and long-term maintainability. In the next unit, we will briefly discuss some design limitations that we have frequently encountered.